prior to that,
Yeah,
and
sure.
let's our other friends join. Once they started, we'll start.
Sure, sure.
Yeah, are you able to hear me, Mukesh?
Yes,
Could you hear me?
yes, Bhaskar, I
Oh,
can hear you.
okay, great. Let me share my screen now. morning, guys. Hope you all can hear me and you can view my screen.
Yes, we can see your screen.
Yeah, Bhaskar.
Okay, great. Yeah, before I jump into today's topics, I would like to understand what we have learned yesterday, and I've asked you to perform some stuff. Asked you to check a few links like Revelo, AWS, Azure, and VMware hands-on labs, and so on. Did anyone tried? Venugo, Mukesh, did you try?
Uh, Actually, Bhaskar, I already have a subscription on Azure, but
Okay.
for the other one, I haven't tried yesterday because after the session I had office for 2 to 11, and then
Mm-hmm.
today morning session. So maybe I'll try later today.
Mm-hmm. Okay.
Definitely.
Fine. Okay. Okay. How about others? Did you try anyone?
No, Bhaskar, I did not.
Okay. Yeah. Please create at least one account and just check the options because as I told in down the lane another 5 years we you possibly not be using much virtualization, right? So everything even customer will be asking you to deploy instances from cloud. You will not possibly you need to have more exposures over virtualization layer itself. So so we have to see the future possibilities along with the virtualization as well, like where we can expand our skills. So the mobility and cloud computing, that's they're gonna play a major role, and especially security, um, cloud security. It's gonna be the heart-rending topics in the future. So along with VMware virtualization, you have to move ahead with such technologies as well. Yeah, guys, you guys put yourself on mute whenever I ask something, then you can answer. Okay, Mukesh, what do you mean by software-defined data center?
So anything that is deployed on the hypervisor.
Hmm. Okay, what is the advantages of software-defined data center? Mukesh?
Yes, so we can see that these are the virtual entities, and we can have multiple, you know, virtual things deployed on the single hardware. So
Mm-hmm.
we are saving some cost there.
Mm-hmm.
Along with that, you can, in the case of disaster recovery or something, we can move these virtual entities to the another hypervisor to keep them alive.
Mm-hmm. Okay, fine. So how about Nilesh? Could you tell me what you mean by a virtual machine? Nilesh in the call?
Sorry, I was in talking the mute. Yeah,
Yeah.
the virtual machine is a software-based the machine that's contain the OS and the resources.
Do you remember I gave yesterday 5 points?
Mm, yes.
Then
Yes. Software-based OS, and then
ah
you're using resources.
This is very important in terms of defining a virtual machine. So it's a software machine. People also call software representation of a given hardware, which has got all properties of a physical machine, made up of virtual devices, and virtual machine is nothing but a set of files. Okay, can anyone tell me what are these set of files? What are these set of files, and which are the files which make up a virtual machine? One by one. Venu?
.vmx, vmfs, vmx, virtual machine
.vmx?
.vmxf, like virtual machine configuration, and vmdk, virtual disk character, virtual disk, this thing, and flat vmdk, which is having a machine data disk, nvram, this is having a BIOS and BIOS configuration, like vmsn, like snapshot data file,
Snapshot state file. Okay.
vmssn, where like suspend file, virtual machine suspend file.
VMSS.
Yeah. .log.
Okay. Okay. Then.
Like vswap.
Yeah. Very good. Yeah. So as you know, so you have installed, you have created a virtual machine, and all these individual virtual machine files just make up one single virtual machine. Yeah, we'll see. We're gonna create an ESX set today, and we'll see, and then we may install an virtual machine on top of it. We'll see. So yesterday we were discussing about the differences between physical and virtual machine, and we just gave an example like the differences between a normal man and an Iron Man. So virtual machine have more power than a physical machine. Virtual machine can do beyond what physical machine can achieve. So let's see from here onwards. Types of virtualization. So there are multiple types of virtualization, and first of all, what do you mean by virtualization? Anyone? Can anyone tell me what do you mean by virtualization? Digvijay?
Yeah, Master. I was actually waiting for someone else to reply. So virtualization actually share the compute resources and mostly the compute resources on the the hardware platform using the hypervisor layer.
Yeah, that's true. So practically, yeah, this is what will happen in virtualization. And then let's see the official name or the typical synchronym what the virtualization layer defines. So here, virtualization is nothing but a technology which transforms hardware resources into software. This is a typical dictionary based wordings where you can see in virtualization it's more like a technology. It discusses about like how exactly a physical machine being transformed into a software based machine. So when you look at the actual answer, yeah, to convert a machine from a physical form to a virtual form, we need some kind of an transformers. Here This hypervisor will act as a transformer. So hardware resource, yeah, computer resource, and the software, it's all about the virtual machine. Yeah. So there are multiple types of virtualization. So can anyone tell me, there are many types of virtualization?
Server virtualization,
Okay.
network virtualization,
Then
Storage virtualization, network
yeah,
virtualization.
yeah. Yeah, if you look at everything now,
Mm.
so the people will define each and every stage as some kind of a virtualization, and people also have the address like para virtualization and so on. There are many type of virtualization, but you look at the main differences between all these virtualizations over here. So virtualization, where you have your CPU memory. Okay, when we say server virtualization, it's mainly speaking about an CPU and memory. And network virtualization, it's example vSwitch. We can call it as a component inside a server virtualization, because when you say ESXi hypervisor, it uses a virtualization technology, and it virtualizes everything: hardware, CPU, memory, and NIC card. And then storage virtualization, again like VMFS, uses a storage virtualization. And when you come to desktop virtualization, we have VDI. So this is, they categorize into majorly four different individual types, but we mainly work on server virtualization. So if you look at the server virtualization, we mostly focused on CPU and memory only. You take any topic now. Let's take an example. You take HA. HA speaks about HA closely dependent on CPU and memory. You take DRS. DRS closely related to CPU and memory. You take vMotion. vMotion is closely related to CPU and memory, because your storage is fixed. Only your ongoing memory instances will be copied, and it's like copy and play or record and play. So ESXi is mostly discusses, or it's mainly discusses about CPU and memory virtualization. And VMware have, that's why they made a different product. For network virtualization they have NSX, for storage virtualization they have vSAN, and desktop virtualization they have VDI. So we feel, as a layman, when we look at VMware virtualization, we feel like okay, everything is virtualized and they have individual functionalities. But if you look at the core, no, we are not virtualizing. In ESXi, we are not making use of the complete network and storage. We are mainly making use of CPU and memory. As you know, software defined data center. So this is a typical example for an virtualized infrastructure. How exactly the cloud layer is formed, or how exactly the hardware and the network layers plays a role in terms of building an cloud layer. So I request you to have a look at this image once. Yeah, if you look at here, the physical layer and the abstraction is nothing but the virtualized layer. On top of it, you have a cloud layer, and you can see it's a public cloud over here, hybrid cloud here. So, as you know, what do you mean by a cloud? Anyone, can you define what you mean by a cloud?
Self-service manageable portal.
Self-service manageable portal? No. Anyone else? People who are getting the Azure training. Hey, can you tell me what you mean by a cloud?
So cloud is something that is providing users some facilities like self manageability. Like they'll be having self portal, like they can manage their resources by logging onto that portal. Then it will be providing you virtualization facility, then pay as you go. Whatever resources you use and on the cloud, you'll have to pay only that much amount.
Mm.
And
Okay. Anyone else? How
Uh,
do you define a cloud?
yes, the cloud. No, no. There is a in the cloud. There is a services are hosted, and no, and all the virtualization as a hosted in the cloud. That's the content. No, infrastructure as a service, platform as a service, software as a service. So that's all hosted in the cloud, and it's manageable via the portal.
Okay. Okay. Yeah. Great. Yeah. The last answer seems convincing. Yeah. See, in cloud, we are getting a service over a web page. Okay. Traditionally, VPN, how VPN works. So, example, you have a VPN client install on your laptop. You just launch a VPN client and then you provide the authentication. It will connect it to your VPN server, and then you can connect to your corporate network. See, when you connect it to your corporate network, you know which network it is. Example, your corporate network is in 192.168.1.x series. You will aware of the subnets, you will aware of the subnet ranges, you will aware of your network. But when you say in cloud, it is a combination of VPNs. You can have multiple networks. It's combined together, and you never know from where it is being listed. I mean, where it is from where exactly it is being hosted. It is been it provides and distributed resources across the globe, and over you can be accessible via an web interface. We have something called CDN, okay, Converged Data Network. So over CDN, when you upload some kind of a data into a specific location, that specific data is being cached and being distributed into multiple locations. Example, in Azure, you have 18 different locations of CDN, where when you copy a data, it is being cached into 18 different locations. Whichever is nearest to you, you can get access from that location. So here in cloud, it's a group of computing resources and its services, which is shared across the globe and which you will be accessing via a web interface. Okay, so here to build a cloud, we need some kind of an architecture. This architecture involves your hardware layer and your virtualization layer. Okay, and each and every cloud service provider will have a multiple sites, and they will have an production. You can see like it will be divided like multiple zones, multiple availability zones and regions. So these regions will have an cache level, a cache enablement like CDN, and the resources being distributed across the globe, and you will be accessing it. If you look at the deep dive, I mean, if you look at the core of the cloud computing, is nothing but a simple VPN. That way, it's like a bridge which is enabled across it. To add it to it, they have enabled a security, and they have enabled an pricing model, and so on. But for a layman, we can make him understand like it's a VPN, as simple as that. See, once you connect it to VPN, right? So you can access everything in your network. Same thing here. When you have an authentication, when you have a subscription, you'll just provide that link and you log in, and you'll have your own group. You will have your own resources. You will have your own network. You can play with that. Yeah, here you can see an example, vCloud Air. So VMware had a product called vCloud Air, and VMware sold this particular business, cloud business, to some other vendor, and VMware doesn't have any cloud-based services or a business as of now, and that's why VMware started implementing their products with AWS, like VMware on AWS Cloud, or VMware on Google Cloud, and so on. And also VMware, you can see here there is something called public cloud. Can you see here? Sorry, this area you can see in the backend it is OpenStack. So, do anyone heard about OpenStack?
Yeah, yeah, Bhaskar, heard, but not aware of like how it works and what exactly it intention to be.
Okay, yeah. See, if you want to know about OpenStack, VMware do have a product called VIO, VMware Integrated OpenStack. It's like an appliance you just download and install, and there'll be a web-based management interface, and you can use it. The OpenStack is more like in private. It used for a private cloud, and there are many companies who adapted to OpenStack, and OpenStack it's like an open forum. So let me bring this up. Like you heard about open sources, open source communities. Open source platform, and this is funded by Rackspace Hosting and NASA. And I would say the OpenStack in future it's gonna overtake the public cloud with their own offerings. I mean, currently it is available and it's like in free where you can download and you can use it. And in future, you may set up your own private cloud rather dependent on the public cloud providers like AWS or Azure. So it tremendously modified the business, and it's active since 2010, and they have new releases coming up, and you can see the latest stable releases. On Feb 28th, they have released a release like Queens, and you have multiple releases every year, and the community is growing like huge. And VMware is also a partner, and let me bring it up. Yeah.
Thanks, Bhaskar.
Yeah. And VMware do have a product called VMware Integrated OpenStack. Let me bring it up. So let me play this.
Are your developers demanding an OpenStack private cloud, but you're concerned about complexity and lengthy deployment times? Deploy the fastest, most reliable, and production-ready OpenStack cloud with VMware Integrated OpenStack. You can be up and running in as little as 15 minutes while leveraging the world's most trusted and reliable virtualization platform. Boost developer agility and innovation with VMware Integrated OpenStack. Leveraging the world's most trusted and reliable virtual little as 15 minutes with VMware Integrated Open.
Yeah, you just have a look at this. Is that audio is visible? I mean, audible to you? Was that audible?
Yeah, but
Yes.
Okay, great. Yeah, you can see here. It's a physical server. On top of it, we have ESXi. On top of it, you have the OpenStack. Right. So VMware provides an appliance-based, like it's like an OVA. You can download and then you can deploy, and then you can deploy. You can roll out instances, like how you use Azure to create a new instance. No, similarly, when you have your OpenStack deployed, and you can roll out your instances. OpenStack is truly an Linux-based source code where it is built on Python programming, and you should know the basics of Python programming. And if you're not aware of the Python program, it's not an issue. Still, you have very good GUI, and you can make use of the GUI as well. And once you deployed, there will be a manageability, like how you have 5480. Similarly, you will have manageable in web link. Through that, you can start your services, and once your services started, and then you can go ahead and run an instances. See, VMware, as I told you, VMware is not doing great at the market because 10 years back, VMware was doing awesome. So there were no competitors, and they were the market leaders. But the days moves on, right? And Microsoft have got in with Hyper-V and its products and services. And later, the AWS came very strongly, their presences, and to compete with them again. Microsoft started with an Azure from 2008 onwards. So it's tough to survive any kind of virtualization product in the market. That's why VMware shift their businesses towards mobility, cloud computing, and network virtualization like NSX. And NSX is not a VMware product. NSX is there was a company who built NSX product, and VMware acquired that company, and they have their own product. And even AirWatch, it's not a VMware company. AirWatch was an individual entity, and VMware found potential in that company, and they have acquired that company. And now they are focusing on vSAN, and this vSAN. It's more like in-house product, and they're promoting on it. Yeah, so my request is, so there are documentations available, and there are downloadables also available. You start exploring these products, because in future, OpenStack and cloud security, cloud automations like VRA and Puppet, Chef. So these products will Ansible. These products will be it's like a more trending or in-demand products in the future. Anyone used Puppet, Chef, Ansible?
No, at least not me.
Okay. So yeah, you can start exploring those products. So I'll just put it down here. So you can just spend a time now. So it will be good if you could spend some time. I'll give you the names here. Docker. You can have a look at these naming conventions, and definitely you're gonna see, you will see the other side of virtualization. See what happens when you start your day, and you will have in your plate, you will have your own cases, and you'll have your own backlogs. You will more focused on that day to get that completed with maximum number of closures. But when you look at the other side, when you come out of your office, and then you have to think, okay, what is trending in the market, and how you can improve yourselves. So these individual platforms will make you to realize the other side of um, the cloud market or the IT market. Okay, we'll come back. Yeah, with you speak a lot. Virtualization layer as simple as that. Again, the same thing. So we have seen the differences between physical and virtual machine, benefits of virtual machine, and in the files which make up a virtual machine, and how exactly the vSphere sits on top of and these resources. So we're gonna see in detail again. So what is the difference between VM kernel and ESXi? Can you see here there are two naming convention here, vSphere VM kernel and ESXi host. What does it mean? Can anyone give a try? What is the difference between ESXi host and VM kernel? Excuse me. Venu?
VM kernel is like a communication channel between VMs as well as ESXi host.
And what is ESXi host?
ESXi host is in software which is containing a OS, all these things, resource pool, everything.
So you mean VM kernel and ESXi are two different things?
No, it is integrated, I guess.
Okay, let's see.
So I think VM kernel is a part of ESXi host, and which actually distribute that compute resources between the VMs, among the VMs.
Okay. Okay, let's do this. Let's see now. You know, every operating system is made up of two things. One is called kernel, okay, and the other one is called shell. So one moment. Yeah, as you know, every operating system is made up of two things. One is called the kernel and the other one is called shell. The innermost layer is called a kernel and the outermost layer is called a shell. So can anyone tell me what is kernel, what it will do, and what is shell and what it will do?
Yeah, actually kernel translate the OS commands to the hardware.
Translate OS commands to the hardware. Okay,
So
good.
it is a main communication layer between the OS and hardware. And
Okay.
VMware have its own kernel. Before ESXi, they are using that Linux kernel. So now they have developed with ESXi their own kernel. So with ESXi kernel, VMware kernel, it is creating the layer in between the hardware and VMs. And whatever it is a transition or data or communication hardware level, it is going to distribute the resources, and all things are happening with this kernel.
Okay. Okay. Shall we try to understand like this? See, kernel is responsible for speaking to hardware layer. Kernel understands only zeros and ones. Okay. When you say shell, it is all about your high level language, HLL. This is low level language. So what do you mean by high level language? See, in ESX CLI, you would have executed a command, no? Let's take an example. ESX CLI network H0 and you're executing a command. Or in the PowerShell, PCLI, you're executing few commands. And these commands are high level languages where you will understand, you will get to know, like ESX CLI network means, oh, it is related to a network command, right? So when you execute this command, so it will go and directly speak to this shell, and when you execute command, the shell will directly speak to this kernel where VMware has built in the backend, like we call it as a VM kernel, and this VM kernel directly speak to your hardware resources. Okay, all this together, your VM kernel and shell. Okay, let's take an example. Shell is your DCUI. In turn, DCI is equal to shell. So VM kernel DCI altogether makes an operating system called ESXi. Okay, so VMware just modified the name. It's the kernel is called as VM kernel, and the shell they has given a name called DCUI. A shell can be anything. A shell can be an API. A shell can be an vSphere client. A shell can be an vSphere client. A shell can be an host client. A shell can be an PuTTY. In any form of which you give an high-level languages. It can be a GUI or CLI. It all comes under shell. Shell means outermost layer of an operating system where you can provide your inputs to the kernel, where you can, if you want to execute something, where you put an input, right? It's a place where you can provide inputs. It can be a CLI or GUI, and that inputs which in terms is received by VM kernel, and then that will understand one. I mean that will convert this zero. That will understand the high level language and convert that into an machine understandable language as zeros and ones. Altogether, VM kernel and shell, it's called ESXi. Is that clear? Is this clear to all?
Yes,
Yes,
Pastor.
yes.
Okay, thank you. So if someone asks next time what is shell, so we can say that vSphere client, host client, DCUI, APIs, PuTTY, any form of giving an inputs, any form of giving in commands. Yeah. The same and physical and virtual infrastructure. You can say physical infrastructure without any hypervisor, virtual infrastructure with an vSphere means ESXi here. Nothing much. And very important thing is the resources distribution. Can anyone tell me how exactly the communication between ESXi and the virtual machine happens? Guys, can you tell me how exactly the communication between the ESXi host and the virtual machine happens?
Bhaskar, I'm not sure on this, but I think VMware tools are responsible for the communication between ESXi host and virtual machine.
VMware tools, definitely not. That is not the only. Definitely, VMware tools is not the only. So you mean to say, without VMware tools, virtual machines will not communicate with the ESXi?
Yeah, I'm not sure. So
Okay. We'll see. We all can give a try, and we definitely somewhere, some or other way, it is closely related. Let's see how we can link together. Okay, any idea like how virtual machine is communicating with the hypervisor?
VPXA will work on this.
I'll kill you. VPXA is nothing but a vCenter agent which runs on the ESXi.
Yeah, but it is like ESXi will command with on this like API, all this thing.
No. So it's good that you gave a try. Yeah, VPXA is an agent which is responsible for vCenter and ESXi communications.
Okay.
Right? By default in ESXi, you will have a user called VPX user, and through him, the agent will work and pass the communications like monitoring and real-time heartbeat info and so on to the vCenter server. But it's not to the answer what I was expecting.
When it is going to be installed on vCenter, that time that VPXA and API will come into the picture, right?
No.
So it will, vCenter will communicate, will monitor this ESXi host or
monitoring, yes. Monitoring between vCenter and ESXi is yes, VPXA. But here the question is how the virtual machine is communicating with the ESXi. Anyone? Mukesh?
No, Bhaskar, I don't.
Nilesh? Okay. Let me brief. Okay. This is a typical example. You see the gray color area over here. This is in hardware. And the blue ESXi. And again, you have a virtual machine. See, ESXi is responsible for abstracting the resources from hardware to the software-based machine, that is your virtual machine. So when you create a new virtual machine, there is something called VMM. Do anyone heard about it? Virtual. Okay, one moment. Virtual machine monitor. So virtual machine monitor, it's like a service. Okay, this service will be running on your virtual machine. This specific service is responsible for communicating with your virtual machine and ESXi. Okay, virtual machine monitor will have a detailed information till your guest operating system level. So virtual machine monitor can understand hardware. Sorry, they can understand. They can understand hardware requirement, and they'll understand gust OS. These two things is performed by virtual machine monitor. Okay, virtual machine monitor is like a service which runs on each and every virtual machine, and through virtual machine monitor, ESXi will communicate. So virtual machine monitor will have information about what is my CPU usage, what is my memory usage, what is my hard disk usage, what is my what is my data transfer over my NIC, and it will also understand guest OS level requirements. Example, if you have configured page file within your guest OS, and it's altogether it is been provisioned from an either an virtual memory or an hard disk, right? So it will have all these informations tracked, and through VMM that information will be sent to ESXi. So as Venu said, like VPXA to monitor. I mean, you brought up a name called VPXA. Yeah, VPXA it's an agent which is responsible between ESXi and vCenter communications. This communication goes via a port number called 902. So here, the similar way, a virtual machine monitor is like an agent which runs on this virtual machine, and this virtual machine in turn communicate with the ESXi host. So do anyone heard about virtual machine monitor anytime?
No, not for me.
Okay. Anyone else?
No.
Okay, yeah. Keep in mind the communication between virtual machine and ESXi happens via virtual machine monitor. Okay, we'll see in detail. And I think we should have some detailed documentation. VMM, yeah. Okay, here we have some clue. Okay, can anyone read this? Can you, are you able to view this, or shall I zoom it? Hope you see this.
Yes.
Yeah, or I can read out for you. The virtual machine monitor, which is the process that provides the execution environment for your virtual machine, as well as helper process known as VMX. Each running virtual machine has its own VMM and VMX processes. Are you getting it? So especially you just look into this. Virtual machine monitor, which is the process that provides the execution environment for the virtual machine. What do you mean by execution environment? Means hardware requirements or any kind of a communication between ESXi that is acting like a bridge. Okay. So the main communication happens via VMM, as you can see here, VMM. Along with VMX. So VMM and VMX makes the communication. So VMX will have the information about the configuration.vmx, and VMM is responsible for the hardware requirements and resources utilization, and and single soul for communicating between ESXi and the virtual machine resources. Understood, everyone?
Yes.
Okay, great. Okay, it's just 11 o'clock now. Take a small break. So we'll take a break like 15-20 minutes, and then we'll come back. Is that fine with you?
Yes.
Okay. Yeah. Hello, guys.
Hi, Bhaskar.
Hello.
Hi, Bhaskar. I'm here.
Okay, okay. Are we missing? I can still see only 5 participants in the list. Are we missing somebody today? Are everybody in the call?
Only 5 only, right? Digvijay, myself, Vivek, Mukesh, as well as this guy,
Somebody
Nilesh.
now.
Nilesh was
Somebody.
there yesterday.
Yeah. Nilesh,
Yes,
Mukesh. Okay. So, okay. Yeah, Venu, your name is not listing here, so that's this thing. Okay, fine.
Okay.
Fine. Then. If you could see my screen.
Yeah, yeah.
Hello? Okay, okay,
Yes.
fine. Yeah, we were discussing about the communication between ESXi and the virtual machine. So VMM virtual machine monitor is responsible for communicating between virtual machine and the ESXi. It's like a service or an agent which runs on the virtual machine, and through that specific service, it will be moved to ESXi host. Yeah, CPU virtualization. Okay, um, it's the same. I mean, as I told you, the ESXi it's morely like an CPU memory virtualizations. And do anyone know like how exactly the CPU virtualization works? And you would have heard about this naming conventions, like virtual CPU, core, logical core, and so on. So let us understand in detail about these things. Guys, you see here, um, you know, we have heard a lot of things like this: CPU, processor, physical CPU, virtual CPU, core, logical core, and so on. So can anyone tell me the differences, or how can we relate it, and how the each and every naming convention differs? I want everyone to give a try, uh, because this is very important, because many places we uses the CPU, and many a places when we are about to apply a licensing, we need to know about the number of CPUs, and we are creating a new virtual machine. We have to assign a number of virtual CPUs, assign number of cores, and we also will be balancing the number of virtual CPUs for capacity planning. Or when you are creating a new virtual machine, we need to have enough resources to create for a new machine. So a lot of things involved with these naming convention. I want you to relate the things, or I want you to individually speak about this individual naming conventions. Would like to understand about it. So start with Mukesh. Mukesh ji, could you please tell me like how each and every naming convention differs?
So Bhaskar, I think there is one more like socket. So I'm kind of
Okay,
confused in between
no
all this
problem.
terminology.
No problem, my dear friend. I'll help you. No problem. You give me any naming conventions, we'll put it together and we'll try to understand. Okay.
Okay.
Yeah. Very good. You brought up that socket. Yeah. I'll explain each and everything, but prior to that, I want you all to give a try so that how we can relate things together.
So a CPU would be the conventional unit that is like we can say that it is the brain of the computer. So like core and sockets, I think those are the parts of CPU,
Mm-hmm.
and then physical CPU would be your physical, and then virtual, that is what you use for a virtual machine in virtual environment.
Mm-hmm. And then what is core? Logical core.
Then core would be again a physical entity, I would say. Logical would be a virtual.
Mm-hmm. What is
Multi-threading, thread, I'm not aware of those.
okay? How about the thread socket?
No, big confusion.
Okay, no problem. Anyone wanna give a try?
No, Bhaskar.
Okay, fine. So let's see how I can relate things here. See now. So these three terminologies are same. When somebody is speaking about processor, CPU, physical CPU, all three are same. Okay, and we'll see these naming in conventions individually. To understand that, let's take motherboard and so when you purchase a new motherboard, right, you will see components like this. A lot of components, right? Mukesh, when you purchase a brand, you hope you would have seen a motherboard, no? Mukesh,
No, actually, I haven't seen motherboard like.
you have never seen a motherboard?
No.
Okay, okay, no problem. Okay, you see here, this is a motherboard without a processor. Okay, just think, this is a motherboard, and this is called your DIMM slots where you put your RAM, and this is your PCI slots, and this is the PCI Express slot, and this is your SATA, and this is your onboard heatsink, and so on. The other components like VGA, USB, and so on. So just think this is a motherboard, and here you have a place. Can you see here?
Yes.
Let me zoom this. Yeah. See, this is called a socket. Okay. When you say a socket, Socket is a place where you will insert the physical CPU or a processor. Okay, this is a pinned socket, and in the modern days we have pinless sockets. Okay, can you see here? This is a socket. Mukesh,
Yes, yes, I can see.
the motherboard, and this is called a socket. Socket is a place where you will insert a physical processor.
Okay.
So we'll come back to our image. So once you put an CPU, it will be like this. See, this is a physical CPU. Okay, yeah, I think that this is a better example to you. So you see here physical CPU, and
Yes.
we will close it and we will lock it. There will be a notch here, and we'll get it locked. And once you lock it, it will look like this. Okay.
Okay.
Yeah, great. I'll come back to our image. So this is a place where you'll put a processor is called socket. On top of it, we'll put a CPU. Okay, and this CPU can be pinless or a pin CPU. There are different versions in it. So let me discuss about a server motherboard. Okay, whatever you see, it's a desktop motherboard now. Okay, now let's see about a server motherboard. Okay, have a look here. These are all 4 different sockets. So server motherboard usually will have 2 to 4 sockets. Socket is a place where you will put a processor, right? So Mukesh, can you tell me now how many sockets you have and how many processors you have?
4 sockets and 4 processors.
Awesome. Yeah. For each and every CPU, there will be a dedicated DIMM slots. Okay. See,
Okay.
this processor is getting a thread from this RAM. This is called RAM. Okay. Whatever you see here. Okay. So can you see 4 different colors here?
Yes.
Yeah. This RAM will give threading to this particular CPU to process the data. Which means, see, when you type something, example, you are opening an Word document within an operating system, that is considered to be a process, or we can call it as a thread. That particular task will be queued. It will be queued in the form of, it will be queued as a process under temporary memory. Temporary memory is your RAM. RAM will provide a job to the CPU to execute. CPU, it will execute, and then if it is, once it is executed, it will be saved under the hard disk. Later, the process job will be in the hard disk, are few tasks where you can directly provide back to the RAM and get it displayed on the screen. So there are multiple tasks, few tasks where it's one way where you can directly process and keep it into the hard disk. The other task where it will return and it will just execute at the run level only. It will go here and it will give it to the CPU and it will run over there. It will never copy anything to the hard disk. So here what you have to understand is you can have multiple sockets and you can also have multiple processors. In this example, there are 4 different sockets and 4 different processors. Each and every processor, there will be a threading or a task or a process that will be provided by the temporary memory, that is your RAM. Whatever you see here, these are all RAM. RAM will provide a job to CPU. CPU will execute the process. In turn, all the CPU are centrally controlled by one single board. Okay, if you look at the OS level now, you will see the total number of CPUs and the total number of cores and everything in one single value. Let me bring up this value here. Okay, core is within each and every CPU. Okay, in other words, one CPU can have multiple cores. Example, quad core CPU. So core is the one which comes within the each and every CPU. Let me put it in this way. Example, one CPU is equal to 4 cores. One CPU, 4 cores. One CPU, 4 cores. One CPU, 4 cores. Can you tell me how many CPU we have and how many cores we have?
So we have 4 physical CPUs here and 4 cores per CPU. That means 16 cores total.
Awesome. So the total number of CPUs, 4 CPU, and the total number of cores,
16
cores. Okay. Yeah, you got the differences now. You learned 3 things. One is called socket, second one is CPU, and the third one is core. Understood?
Yes. Yes.
Yeah. So we have 4 CPUs and 16 cores, right? Now we'll see the other naming conventions. So we understood core. Now we'll see a logical core. Logical core is the one which you cannot see, or which you cannot directly control it. That has to be executed via, or that can be controlled via an hypervisor layer or an operating system level. Okay, so what you can do is when you enable a multi-threading, example, okay, let's see what you mean by threading first. Threading means one single task which is given. Any processor can execute a job one at a time. Let's take an example. I have a doc which I opened, okay, or which I'm executing something. The doc will first go on run under that particular process will be queued under RAM. RAM in turn will give the task to processes to CPU. This is called one thread. Okay, now I have given only one task, right? So it is executed one process. Now just think, this is an AD server, AD or a database server. Okay, do you think you will have only one task at a time? You will have thousands of individual tasks, right?
Yes.
So these tasks will be generated and it will be saved under all this RAM. So what happens here? Multi-threading. So this CPU will speak to other thread. See, this is also a RAM now. This is also received. So it will execute like this, and and it will execute like this. So when you will receive multiple threads from multiple temporary memory to one single CPU. So one CPU is capable of executing multiple threads at a time. That is called multi-threading.
Okay.
Okay. Yeah. So many threads. Example, 4 different threads given to the CPU. CPU will look on the priority, but one at a time. It will execute. It will take all 4 threads. It will process it. Okay, but one at a time. It will execute individual tasks. So that is become multi-threading or hyper-threading. Okay. Now, so when you look into the logical cores, how this works? When you enable multi-threading, right? Additionally, whatever the individual cores you have, right? That individual core will become a multi-core. It will become a logical core within this individual cores. Okay, how this works? See now. So logical core is equal to, I'll put it in notepad. Logical core is equal to number of physical cores plus virtual cores. So how many cores you have? How many physical cores you have as of now?
16.
Cores plus when you execute a hyper-threading now, so each and every CPU is capable of executing multiple threads. So always your virtual cores will be always equal to the total number of physical cores, that is 16. So the logical cores is like 32. Virtual cores which you cannot see, physical cores which is defined by default. All CPU manufacturer will give you the core information. Virtual cores will come into existence when you enable multi-threading. So it will, each and every core will enable you to process 2 or more jobs. So at least it is capable of executing 2 or more jobs. So will take exactly the same size as your existing physical cores. So in that case, it will become a 32 cores. So you can compare, you can take any CPU, whatever the number of physical cores you have, okay, double of that physical cores will be your logical core. And this virtual cores will be executed only when you have hyper-threading enabled. When you have hyper-threading enabled, you will have the logical cores listed to you. By default, everyone will enable multi-threading because that is the purpose of the CPU. Nowadays you will never get a CPU without a multi-threading enabled, okay, or an hyper-threading enabled. Okay, thread is nothing but a task or a job or a process which is queued is QUEUD, which is queued to execute in CPU. It can be queued or it can be executed. It's a task. It's a task or a job or a process which is queued to execute in CPU or executed in CPU. Okay, that is thread. This is nothing but a physical where. Now can you able to can you able to relate the things, Mukesh?
Yes, Master.
Yeah. So core, it's again defined in physical CPU. Now, what is virtual CPU? Virtual CPU is equal to total virtual CPU is defined by again, virtual CPU can have a visibility to 32 cores. I can mention like and 32 cores. Okay. CPU is equal to processor. Processor is equal to physical CPU. Virtual CPU is nothing but a logical CPU which can make you which you can make use of 32 cores. Okay. And core is the one which is defined in the physical CPU. If you purchase any physical processor, the core is by default defined. And logical core is nothing but number of physical cores plus virtual cores. So if you want to make use of this virtual cores, you need to create virtual CPU. As I told you, you do not have a direct access to make use of this virtual cores. For that, we create virtual CPUs. Okay, multi-threading is nothing but multiple tasks or a thread being executed by a single CPU at a time. Thread is nothing but a job or a task or a process. Socket is a physical location. Can you able to relate? Can you able to relate the things now?
Yes.
So since long, we as an VMware engineers or anyone, these topics are always confusing. Okay, what is virtual CPU, physical CPU? The virtual CPU is nothing but it's again a CPU only, your physical CPU only. You cannot assign you cannot go beyond the course which you have. Example, maximum you can if you want to assign 32 cores, you do not have an option to directly control this 32 cores. In that case, we will create a virtual CPU. Example, you create a new virtual machine, you want to assign a CPU to that machine, then maximum cores you can provision is 32 only. But in physical CPU, you cannot take advantages of this 32 cores. I mean, you cannot split it in the physical CPU. I mean, you do not have an option to assign a physical resources to another machine. But in virtual CPU, you can segregate it. Let's take an example. One VM with 2 vCPU, and you can assign 4 cores. And keep in mind, maximum you can assign 32 cores only. You cannot assign beyond 32 cores. This is max. So one VM, you want to assign 2 CPUs, and these 2 CPUs is not a physical CPU. These are all virtual CPUs. Okay, why we are creating this virtual CPU? Because I want to execute, I want to control this 4 cores. Okay, that's why I've created a virtual CPU. So maximum I can have 32 cores. Understood?
Yes. So in that case, the total number of CPUs, as in all, that would be 8 for this virtual machine, right?
Correct.
Okay.
No, you said 8?
Yes.
No, come again.
Like you said, for one virtual machine, we're giving 2 CPUs and
Correct.
then assigning 4 cores.
Correct.
So in and all, the CPU count, there would be 8 or?
No, it will be 4 only. See, you want to make use of the cores here. You're not making use of the CPUs here. Okay, you cannot assign beyond the number of CPUs available here. Maximum. Let's take an example. How many CPUs we have? Here I have written now. How many CPUs we have?
4.
So how many physical cores we have?
16.
Yeah. So when you add another 16 virtual cores, that is enabled when you have a multi-threading, then you will get 32 logical cores. Keep in mind, if you have only 2 CPU, you cannot assign more than 2 CPU to your virtual machine. Okay, it's all about the cores which you are splitting to the virtual machine.
Okay.
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 Okay. Okay. Let me try. See, let me show you this article. Let's take an example. I have one single CPU, that is Core i5. No, we'll do one thing. When you are creating the virtual machine, I'll show you at that
Uh,
time.
yes, actually, Bhaskar, I got confused. Yes, you're correct. So, I can remember when we assign, for example, 2 sockets and then 2 cores, so that counts as a 4 total number of CPUs there.
Yes.
Yeah, so yeah, I got it.
Yeah. So you cannot go beyond your physical CPUs. Let's take an example. No, yeah, this is the best example. Yeah, you see here. You see here how many CPUs, physical CPUs you have? 1,
4.
2, 3, 4. No. See,
Yeah.
maximum CPUs you can assign to a single virtual machine is 4 only. Okay. You
Okay.
can map, but the number of cores, where is the core? Courses which is running each and every CPU, right? That you can increase it, but
Okay.
maximum is 32. Okay.
Okay.
Yeah.
Got it now.
Okay. Then move on to host memory. Okay. Question to you all: can you over provision your virtual memory?
Yes, can do that.
Okay. How will you achieve it? How can I over provision virtual memory?
So a memory can be over provisioned. Like there are few technologies used by the vSphere, like ballooning, and there are a couple of more. So memory or allocation is possible.
Okay. Yeah. Good. Okay. Anyone else? Can you guys tell me how you can over provision your memory to the virtual machine? Nilesh.
Memory over provision not allowing there. Now, if we are selecting in the that virtual machine properties, it's not allowing. It's not the we cannot over provision.
Okay. Let me put it in this way. So if I put a question in the form of word, you will understand, I think. Let me put it in this way. See, I have ESXi host, size 32 GB RAM only. Okay. I will create one VM. For this single VM, I'm assigning 34 GB. Okay. And some CPU and all. The question here is, can I power on this VM or not? What will happen? What will happen to existing ESXi since over provisioned? See, you see now who was giving this answer? I mean, you said you cannot provision. Who's this? Hello, guys. Somebody was answering to me question. No, who was that?
I think it was Venu.
Okay, Venu.
No,
Now,
Big Ben.
now the question to you. See, it should be clear now. Your question. See, I have a ESXi host of 32 GB RAM. Okay. On top of that ESXi host, I have created one VM of size 32 GB. This is RAM. Let me put very clear. RAM. Can I power on this VM or not? You tell me now.
We can power on the PM.
Okay. Will it power on or not?
Yeah, it will power on.
Okay, great. Yeah. Yes, it does. So virtual machine will power on.
So
Okay.
actually, you don't reserve a specific memory. VM should be online, like should put on. So like the minimum with the available resources. So VM actually use the VM which is required, not what is allocated or provisioned.
Okay, well said. Yeah. Yeah. So you can over provision memory, virtual machine memory, and virtual machine will power on, and it's not gonna use 34 GB of RAM because there is something called minimal virtual hardware requirement. Okay, and this you can see automatically when you create a new VM. Select a specific VM. Now let's take an example. If you select Windows XP, right, each and every operating system have a minimal hardware resources. Windows XP can power on in 256 MB of RAM, and it just need 5 GB of hard disk, and it just need one CPU. As long as you have these resources available, this virtual machine will power on. Okay, see this 34 GB RAM what you have, this one I have not did any memory reservations. By default, all these virtual machines, when you create, it will have a by default, when you create a new virtual machine, memory reservation will be available, but you are not limited. Okay, there is a strict level limitation where you can go back to this machine advanced option, and you can mention value. Example, this is what my start value and this is what my end value are. Here this is the value where it should not use beyond this particular limit. In that case, virtual machine may not power on if you have a strict individual virtual machine level reservations. By default, I didn't get any reservation, and it takes, I have just provided 34 GB of RAM, and it first will go and check whether this VM have minimal hardware resources. If this is available, I'll go and back and power on. And moreover, when you start utilizing the resources, example, by default ESXi will consume 2.5 GB of RAM. Okay, even though the minimum hardware requirements 4 GB, if you look into a specific ESXi host, right, it will not take beyond 2.5 GB, or it will take lesser than 3 GB. It will have other resources free. It will keep the other resources free. I mean, the rest of the resources free. So when you create a new VM, it found an minimal hardware resources, and it is powered on. And what will happen to an existing ESXi over provision? Nothing will happen to the ESXi, because ESXi uses memory reclamation techniques. You heard about memory reclamation techniques? So one I have heard, it's called memory ballooning. Then memory compression, and then host cache, and transparent page sharing. So ESXi uses multiple memory reclamation techniques, so that whenever it feels like its memory is going beyond the limit, over provisioned, it will use all these techniques to keep virtual machine and ESXi alive. Guys, have you heard about this memory reclamation techniques? And one more thing, host swap. We'll see each and every individual techniques in detail when we discusses about resources monitoring. We'll see individually, but I want you to bring it now, because we need to understand whether memory over provisioning can be possible or not. Okay, any one of you Have you heard about this memory reclamation techniques? I am very sure you would have heard about this because we use VMware tools. In VMware tools, we have one specific driver called VMMCTL. Can you answer, Mukesh? Have you heard about any of this?
Yes, I had heard about memory ballooning and host swap.
No swap. Okay. How about other people? Menu.
Yeah, heard memory compression,
Huh.
everything, the ballooning, VMware tools, VM, all these things. Yeah,
Okay, nice.
but we don't know that how it is worked.
Okay. Okay. I'll explain everything. I will individually I'll explain when we speak about resources monitoring. Okay. So the question is, can I over provision memory or not? The answer is yes, and we have seen how this works in the backend, because in the backend it takes only the minimum hardware requirement. Whenever by default when you create a new VM, no, it simply select any OS. It will list out the minimum resource. Example, if you select Windows 10 now, automatically it will select one CPU. It will select like 2 GB RAM. It will select like the recommended size like 30 GB or 40 GB as such. So whenever it could able to see those minimum resources when you are about to power on, right, it is all set to bring up the machine online.
Bhaskar, I have one question.
Yes, please.
Like when you say we are assigning reservation to a virtual machine,
Yeah.
so does that mean that we are assigning a dynamic memory to the VM?
Yes.
Okay.
We are not reserving it. I mean, we are just assigning it whatever the resources which you assign now. It's not a strict reservation.
Okay. So virtual machine will take that RAM which is required at that moment, like
Correct.
based on its need.
Correct.
Okay. Because in Hyper-V we can directly assign startup memory and then dynamic RAM, so it grows as it needs.
Okay, here no, we don't have such concept. We will assign one time only by default. Whatever you assign now, that is like a dynamic memory itself. Because if you want to use a memory ballooning, no, so dynamically the ESXi has to pull the resources from a low utilized memory to high utilization virtual machine. Okay, if you have a strict reservation, right, in that case it will never allow the resources. It will say this is what the resources I have. I will never support a memory ballooning because I am not dynamically assigned. It's a strict reservation for me. So that's why in production we rarely use a strict reservation, because strict reservation will also affect the DRS. So many things we'll discuss whenever we start discussing about individual reservation, no? Or when we speak about VAP or resource pool, no? We'll discuss in detail.
Okay.
Okay. Moving on. Networking. So yeah, can you see here one virtual switch? It's connecting to multiple virtual NICs. Okay, I have few questions to you all. So can you tell me, can I assign one single NIC card to multiple V switches?
Yes.
See, I'm repeating the question. You should listen. Who is this? Mukesh, is it?
Yes.
I'll write down the question to you. See now. Can I assign one physical NIC card to multiple V switches? Example, can I assign VM NIC 0 to V switch 0 and V switch is 0 and V switch 1? Do you got the question now? See, this is the best example for you. Now tell me. Yes or no?
I'm not sure.
Okay, Venu.
No.
Okay. Digvijay, Nilesh. Hey guys. Vivek ji. You guys are there? Hello?
No, actually. VNIC and VMNIC, that's a difference.
Okay. Yeah, correct. You're right. So whoever said no, correct. Because you cannot assign a single NIC card to multiple V switches. Okay. Very good. Now I have one more question. Can I assign multiple physical NICs to one single V switch? Okay.
Not sure. Actually, I don't know how this networking works with VMware. So
Okay. Okay. No problem. No problem. You just look at this answers, because when I'm teaching about standard switch now, I will teach you from the scratch. Okay. I'll teach you from the scratch. So you will learn everything. Now you just understand the, or you just make a note of thing, whatever we are learning now.
sure.
Yes, we can assign.
Okay. Very good. Very good. Very, yes. We can assign multiple physical NICs to one single V switch, but we cannot assign one single physical NIC card to multiple switches. This is a golden rule. Okay. If you know this golden rule, your networking will be very simple. Okay. When you are learning networking, this will be very simple. This is a golden rule. Yeah. We'll come back. So here, by default, sorry, I can see background noises. Could you please mute yourself? Yeah, here. By default, when you install ESXi host, a vSwitch is created. This virtual switch is called a standard switch, or we also call it as VSS, vSphere standard switch. vSphere standard switch is equal to vSwitch. Our standard switch is equal to vSwitch. Yeah. And this switch is capable of communicating between multiple individual virtual machines. By default, a vSwitch is built in with 1024 ports, but this can be increased to 4088 ports. Maximum you can increase to 4088 ports. Moving on to file system. Okay. Vivek, can you tell me what you mean by a file system? Is Vivek on the line? Hello? Guys?
Vivek having the mic issue. He's typing in the chat.
Okay.
Okay.
Okay, Nilesh, what do you mean by a file system?
The file system is the content saving the data. It contains sectors, and it will not exactly explain the definition, but it's type of the NTFS. Then the VMFS. That's the file systems.
Okay. Okay, anyone else? What do you mean by file system?
I would say simply how the data is stored
Okay.
and retrieved actually.
Okay, yeah, you're giving an airline answer. Yes. Anyone else? Yeah. Okay. See here, when you say a file system is nothing but a structured data. Whenever you format whenever you format, right, it will create a structure, but it'll have a header, but it'll have an head references, it'll have a sector references, it'll have a directory architecture. We call it as a directory architecture. It knows how many sectors this disk has got, and how many tracks it has got, and where is the header is pointing to, and each and every Unicode will have this info. I mean, it will have information about each and every Unicodes. So when you say a file system, this directory structure is, or the directory structure is created, and this helps you to keep the file system. This helps you to keep individual file extensions. Example, .exe does not understand the blocks directly. .exe understands NFS. .exe understands NTFS. So when you say if you want to execute a specific file, it has to be kept under a file system. This file system will have a directory architecture. So this directory architecture will help you to keep the files. As simple as that. Yeah. So there are multiple, there are many operating systems available in the market, and the legacy file system is NFS, Network File System. And we have for Linux, we have ext2, ext3, ext4. And you all know for VMFS, it has got its own file system called Virtual Machine File System. And the Virtual Machine File System have different versions. I want to put it in this way. VMFS 1, VMFS 2, VMFS 3, VMFS 5, and very recently from 6.5 onwards we have VMFS 6. Okay. So ESXi do have a proprietary file system called Virtual Machine File System. It starts from 1, 2, 3, 5, and 6. And we were using these file systems in the late ESX 2.x versions. From 3.x onwards, we started using VMFS 3, and VMFS 5 we are using still in. It started from 5.0 and 5.0, and we are still using it in 6.x also. So our ESXi 6.5 still understands VMFS 5. Okay, and by default, when you create a data store, it will go and reside under VMFS 5 only. It's the default file system version on ESXi. If you install ESXi, right, by default it will create in VMFS 5 only. Anytime you can go ahead and upgrade that version to 6. And if you want to, let's take you have a new LUN and you want to create a data store. In that case, you will have an option to create either 5.x or 6.x. But keep in mind, by default ESXi gets installed on VMFS version 5.5, it is capable of supporting, it is capable of creating or supporting a data store with the version VMFS 6. Okay, understood? Hello, guys?
Yeah,
Yes,
Bhaskar.
Master.
Yeah, please, anyone respond, so that I feel like I'm not getting any response from other side. So,
No, if you are, like if I in the mic, no, you will get the background noise.
background noise. Okay.
Yeah.
Anyone, yeah, anyone in that case, that should be fine. And you also should, yeah, I want to bring this point. Yeah. So till the VMFS 5, we had a file limitations of it's like 35,000 plus files. But in VMFS 5, we can go up to 1,40,000 plus files. What does mean this file count? See, since it is a directory architecture, right? This specific file system can maximum capable of holding the record of up to 35,000 files only. But in VMFS 5, this version has got, this has got increased to 1,40,000 plus files. And in VMFS 5, you can have an individual file size up to 62 TB, and the maximum data store support up to 64 TB. So what does it mean? So ESXi can see a LUN of size 64 TB. Okay, once you format it, and in that particular data store, you can keep a single file of size up to 62 TB. Understood?
Yes.
And in vSAN, it's altogether an different version. We call it as VMFS-L. That is called Leaf, a virtual machine file system, Leaf. Okay, so you should know about all these versions. For ESXi, we use all these versions like VMFS 1, 2, 3, 4, 5, 6. And for vSAN, we use this VMFS-L. Okay, if you want, you can make a note. Yeah. As you know, all your virtual machines will be saved under saved as a folder. Example, my virtual machine. Okay, let me put it in this way. Mukesh, can you see a folder here? VM3.
Yes.
Can you tell me the name of the VM?
VM3 itself.
Oh, okay, VM3 itself. Correct. Now I have questions. Can I have inventory name? So you got the question here. So let's take an example. In ESXi, I have a name called VM67. Okay. And in the data store name, I have a name called VM3. Okay. Can anyone answer? Yeah, not Mukesh. Can anyone can answer? Can I have a inventory name different and a data store name different for a virtual machine? Or it has to be the same?
No, it can be different. No issues.
Okay. Yeah. So Mukesh, for your understanding, in the inventory, whatever you register, right, it can have your own name, whatever the names you wanna give it. Example, if you wanna give a name called VM7, VM67, it all matters what you kept it on the data store folder, because inside this data store folder, all your virtual machines will start with the all this virtual machines start with the name VM3. Example, inside this folder, the name will be like VM3.vmx, VM3.vmdk, VM3.vswp. So it will be like this. Inventory name can be different and virtual machine name can be different. Okay. To understand the perfect, see, it's always recommended to see a perfect name for your virtual machine is you open this VMX file and you can see a display name. Okay. And you will also see the virtual machine location. Okay. The display name can be different. We can also call it as it's a display name. One more name for your inventory name is called a display name. Yeah. When I can hear a background noise, you mute.
I'm sorry, Bhaskar.
Yeah.
So Bhaskar, for example, I have a Windows VM, and if I change the name, computer
Just a
name
moment.
inside.
One moment. Okay. Now I just connected the charger. So it should be fine. Yeah, you were asking something, Mukesh? Yeah, go ahead.
Yes. So, for example, I have a Windows VM, and I changed the computer name inside the OS, so that will be reflected in the VMX file.
Can you come again? Repeat your question.
Like, for example, I changed the computer name inside the OS.
That will not take effect. No, computer name is altogether different from virtual machine name. So VM name will, there is nothing to do with the Gust OS level virtual machine name. Gust OS level computer name.
Okay.
You understood?
Yeah. So in inventory, if I add underscore old to a virtual machine name, so this name will reflect in the VMX file.
That name, yeah, that name will reply. It will show the display name. Yes, whatever the name you keep now in the inventory, that name will be there as a display name.
Okay. Okay, got it.
Okay, hope you understood. Now, if not, I can show you a live demo to you.
No, I got it.
Oh, got it. Okay, fine. If you got it, that's fine. Okay. So now, yeah, it's all about the clients now. So guys, you see here, there are three type of clients: VMware host client, vSphere web client, and vSphere client. Pay attention here, everyone. There are three different clients. Can you see this vSphere client? VMware stopped giving in support for vSphere client in 6.5. So, but still, why they are mentioning vSphere client here? So, what they are trying to say here is HTML5 client is equal to vSphere client and web client and host client. Host client is for ESXi, web client is for vCenter, and HTML client, HTML5 client or vSphere client is equal to, it's for again for vCenter server. Now onwards, if VMware is specifying anywhere vSphere client, which means they're pointing to HTML client. Do anyone use HTML5 client with limited functionality when you're trying to connect your vCenter over a web page interface? Guys, do anyone use HTML5 client? I'm sure everyone would have used web client, and guys, anyone there? Can you answer to my question? Have you used HTML5 client to connect to vCenter?
VI client is an HTML5 client. No, right?
Yes or no?
Yes.
Okay. So here, whenever you see a vSphere client, they are pointing to an HTML5 based client only. So no, don't get confused, because vSphere client, I mean the traditional .NET based vSphere or C# client or .NET based client, which is created by VMware, it's not supported in 6.5. Okay. And you cannot manage a vCenter via a vSphere client. Whatever the vSphere client we are seeing is, it's an HTML5 based client. Okay, and web client, as you know, it uses a port 9443, and this is a host client which uses a port 443 or 902. So it's very important. You should also make a note of this port number. So vCenter uses 9443 and ESXi uses port 902 and 443. Yeah, this is also 9443. This is an URL which is used to manage like vCenter server / vSphere client. You can manage your vCenter server. HTML vSphere client, no difference. Yeah, here you can see HTML based vSphere client. What does it mean? HTML based means that is HTML client, HTML5 client. Yeah, and you see the components of your web client. See here, VMware uses Adobe Flex Client application in the browser. So whenever you install vCenter server, right, by default web client components and all, it's installed together. Okay, and you no need to install a separate web client plugin to manage a vCenter server. So this is in earlier version. Example in 6, no, you have to download this client integration plugin if you want to manage. Now we don't need it. You don't need any client integration plugin, or you don't need to have any separate installation packages. It is all part of the vCenter server itself. When you install vCenter server, you are all set to go. The only thing you have to provide is the URL path, that is vCenter server :9443 / vSphere client, or vCenter server / vSphere client. Automatically the port will get selected. The HTML client, that is HTML5 based web interface. Here it's the host client. So VMware introduced something called ESXi host client. This is not available in previous version. They have introduced from 6.5 onwards, where you can manage your entire ESXi itself through a web interface. Previous version we had, we used to call it as a web access, where you can browse a ESXi host and you can upload a file or download a file from the data store. We had that file, that specific web page used to give a link to download vSphere client and so on. But from 6.5 onwards, you do not have such interface. You do not have such web links, where they introduced with a naming convention called host client, where you can directly manage your ESXi host like how you used to manage via vSphere client in previous versions. About shared resources. Okay, guys. So now what we need to do is we have to install ESXi. So please log into your machines. I have provided you the TeamViewer ID and password. Kindly connect your individual machines. And in the desktop, I have kept a folder called vSphere 6.5 resources. Okay, if you open, you can see an ISO. And let me show you the ISO file name so that you can open that ISO file. Or I'll just connect it to one of your TeamViewer machine and I'll show you. And since we use an trial licensing, and my session would be disconnected in every 5 minutes, so let me show a simple example. Let me connect to machine 1. Okay.
Bhaskar, how much time it will take?
For what?
So installation?
Installation will take lesser than 15 minutes, 10 to 15 minutes only.
Because almost time is 12:50, so yeah, we have to get ready for the office and all.
You just start installation. No, at least today we'll finish off with the ESXi installation. It will not take more than 10-15 minutes.
Still, we have not taken a bath.
Oh, okay. Fine, no problems. And then we'll continue from next class. That's fine.
Yeah. So it will be the continuation. It will be there. See, now installation again. If someone will get error, so we have to find out. So that is the reason.
Okay, no problem. We'll continue. So the thing is, you just log into this machine. At least make sure that you have your machine.
Yeah. Okay. We have logged in.
Okay. If you have logged in, that's fine. Yeah. Okay. That's all I needed.
Straight away, we'll go for the installation.
Fine, guys. Hope everyone have got the email with the individual credentials, right? Please verify to me, because no one responded back to me on the credentials.
Yes, I received, Nilesh here.
Okay. How about Mukesh?
Yes, I have received.
Okay. Digvijay? Hello? Okay, I think Vivek have a voice mic issues. Fine, guys. We'll continue from Monday, same 9:30 a.m. So whatever we have learned, kindly have a recap. So I think this session is recorded. Whoever is recording, so kindly share it to other people in the group, or you just send a link to all, so that everyone can review it. Okay.
Yes. Okay. Thank you.
Fine, guys. We'll see first 4 classes. At least 4 classes will have very basics, and later it will be more on practical oriented. Okay.
Yes.
Okay, guys. Then see you on Monday.
Yeah.
Bye.
Bye. Okay. Yeah. Bye.